Hi everyone, my name is Andrew Mortellero, and I will be presenting on Sumo, which is one of the simulators we use in our project. So what is Sumo? Sumo stands for Simulation of Urban Mobility. It is a software package that was developed by the German Aerospace Center, and it's open source and simulates road traffic patterns. It is used extensively in many different areas, but its relevance to our project is in that it is used to simulate vehicular communications. What's special about Sumo is that it has a capability of space-continuous and time-discrete vehicle movement. So Sumo comes with a lot of different tools and options and scripts, and so the ones that I used were Sumo itself, which is the command line simulator, Sumo GUI, which is a graphical user interface where you can view scenarios and your road network, NetConvert, which imports certain files and generates a net file for you, DoRouter, which imports trip files and generates routes. I'll get into that later. And then finally Trace Exporter, which takes certain files and then generates a mobility trace to be used later in NS2, or in our case, NS3. So our goal in using Sumo was to create mobility traces for a Manhattan grid. A Manhattan grid uses a grid road topology in which mobile nodes can move along the grid of the horizontal and vertical streets on the map. So there's three choices for any mobile node, and that is straight, left, or right. So what the paper called for was a Manhattan grid of 25 intersections spaced 5 meters apart. Now what this looks like in Sumo is that we need to first build a road network of nodes, or intersections, and then edges, which are the roads between them. And then we need to simulate a scenario that is matching the paper's description, which is that of 21 cars going through this network. So I've included a block diagram to help explain how Sumo works. So on the road network definition side, we have these three input files. A node file defines all the nodes in the network, the edge file defines all the roads between them, and then the type file has some extra options such as the amount of lanes and the priority of different lane movements. Once these three files are made, we use this tool called NetConvert, which then turns those into this net file right here that actually defines the road network and can be viewed in Sumo. On the other hand, we have this route file right here, and the route file basically lists every vehicle and the exact edge, all the edges that it traverses throughout the simulation. Now for 21 nodes, that can be kind of cumbersome and lengthy, so they provided a tool called DoRouter, which basically takes an input trip file and generates that route file for you. And the trip file is not as hard to write because all you need is all of the vehicles, so 21 vehicles, and then there's starting positions and then ending positions. So once you have the network defined, which is in this net file, and then once you have the actual route defined for the scenario, which is in this route file, you can use Sumo to create the Sumo configuration file, which is right here. And then finally, once you have that configuration file, Trace Exporter can be used to output the TCL script defining that scenario, which can be later read in NS3. So that's it for the presentation part, but now I'd like to show you an actual simulation of our network. So I'll quickly go over the files again. So this node file has all of our nodes listed from 1 to 25, along with their x and y coordinates. The bottom left coordinate here starts at 0, 0, and as you go on the x-axis, it increases by 50 because they're spaced 50 meters apart, and then the y-axis increases also by 50. This edge file defines all of the edges between nodes. For example, there are two roads between nodes 1 and 2, one from 1 to 2, and then one from 1 to 2. I've also labeled these edges with this convention to where any horizontal edge starts with an H, and then the actual path from where it's coming from is the first number, so in this case 1, and then the second number is where its destination is, which is 2 in this case. So another thing about this edge file is that it has a type here, and the type is provided in another file which gives you some preferences such as the priority the number of lanes, so since the paper called for 5 lanes, that's why we have 5, and then the speed, which is the 60 miles per hour. So once you have those files, you need a netc.config file, which has this following format, and you basically just include all 3. And using netconvert, you'll actually get your net file. So on the route side, we need a route file to define the actual scenario going on. So here I've just defined all my different trips. So I have 21 cars, so that's going to be 21 trips, as you can see here. And then I've said where I want them to start, so this is the from, and you include the edge it starts from, and then finally the edge that it lands on, which is this 2. And then using doARouter, which is a script, it will output this route file, which actually will have the same ID, and you can configure its depart time, its depart speed, and its arrival speed. And then also it includes all the edges. So for instance, my first trip is starting from edge V2 to 7 and ending on edge H22 to 23. And in here you can see that that corresponds to V2 to 7 and then H22 to 23. So now I'd like to show you our Manhattan grid model. So here's the actual road network. So once you've created your net file, you can load that into here and view this, but you need a scenario to actually see anything happen. So each of these squares here is an intersection, and like I've said, I've labeled them 1, 2, 3, 4, 5, 6, and so on. So now what I'll show you is I'm going to set the delay to 500 milliseconds so that you can see them. And like I said earlier, I released a car every 3 seconds. So once I run the simulation, you should see a new car roughly every 3 seconds. So here we'll start. You can see the first car right here. Another car is right here. And every 3 seconds, a new one will be dispatched. And so this simulation shows the actual traffic patterns of the cars. And so what we do with this is we create a mobility trace from Sumo to later be used in NS3. And then NS3 will basically use the movement of these nodes as its nodes, and then it'll map the routing protocol on top of those nodes so that we can view different performance metrics. That's about it for my part, and thank you.